All right, so if you've viewed the first video, you will notice that we talked about quadratic expressions. So quadratic expressions have this form ax squared plus bx plus c. All right, and now we're going to introduce this idea about quadratic equations. Okay, so quadratic equations is very simple. All we need to do is add an equal sign to this expression. Now we have a quadratic equation. Okay, now where it gets interesting is there's actually other ways you can write this quadratic equation here. Okay, so let's break down the quadratic expression first of all. So we have ax squared plus bx plus c. Okay, so now let's just think about this expression. Well, I said in the earlier video, what defines a quadratic is this x squared piece. We have to have this x squared piece, okay? So actually, we can write a quadratic expression like this as well. Ax squared plus bx without this c. So in this case, c is equal to 0. That is allowed to have a quadratic expression without a c. So an example of this would be something like 2x squared plus 4x. So notice there's not the third term, which is the constant term. All right. And we learned how to factor these. We would do the table method, wouldn't we? So we would do the table method and we would factor them. All right. So let's look at a different type of quadratic expression. We could also have ax squared plus c. So in this example, the b is 0. And if you have b is 0, 0 times x is 0. So this middle piece is gone. Okay, and if you want to see an example of what we have here, we could have ax, pardon me, let's just say 1x squared, so x squared. And let's imagine our c is a negative number. So imagine it's negative 4. So c can be positive or negative. So in this case, c is negative 4. So you'd go ax squared plus negative 4, which is the same thing as this. And we learned how to factorize this one. It was what we call a difference of squares. So x minus 2, x plus 2. All right. So we have that. And of course, so we have so far 3 terms. In this one we have 3 terms. In this expression we have 2 terms. In this expression we have 2 terms. And of course, the most simplest one we have is just ax squared. So in this example, both b and c are equal to 0. And there's not much we can do with this. So you have to be able to recognize what expression does what, because when we're solving quadratic equations, depending on which expression you have, you can do certain things. All right. So let's draw a line here and examine some of these. Okay. So the easiest one to examine, first of all, is this one here. So I'm going to call this A here. All right. So in A, if I have a quadratic equation that looks like A, I could have something like this, which is equal to 0. So if I write this out, I could have something like 1x squared minus 4 is equal to 0. And now we want to solve this. And we are going to use the same kind of rules that we've been learning and using for linear equations. So what I'm going to do is I'm going to, first of all, put negative 4 on this other side. So the x squared is isolated. So I have 4. And now I want to eliminate this x squared, the square on the x squared. In order to do that, we square root both sides. So if you ever square root a variable squared, you get its letter just on its own. The square is eliminated. And of course, if you square root 4, you should get 2. But with a square root, you have to remember that there is always a plus answer and always a minus answer. For example, if I would put negative 2 into this expression just to check if it's write, if I have negative 2 squared, which is x squared, subtract 4, do I get 0? Well, negative 2 squared is 4. 4 minus 4 is equal to 0. So that means that my answer has to I have to remember to add plus and minus to any square root that I take. So quadratic equations, they will always have two solutions. All right, there is one exception, but in general, we always will have two solutions. So in this example, we have x is equal to 2 and x is equal to minus 2. Okay, so that is for part A. So if you have ax squared in a number, we have to isolate and for x squared, and your final step will be taking the square root. So if I take another example, let's say I do this. So instead I'll have 2x squared minus 16 is equal to 0. I'm going to put the 16 on this side here. 2x squared is equal to 16. I'm going to divide by 2 on each side to get the x squared on its own. And then finally, I'm going to square root both sides, so I have my final answer. So x is equal to plus or minus square root 8. And there we have it. So that is this form here. So if I put a box around it, that is this form here. It's very easy. You put the number on the other side, isolate for x squared, and take the square root of it. So we have types like this. All right, the second type we're going to look at will be this one here. I'm going to call this B in the example. So in this example, this looks like ax squared plus bx equals 0. So here's an equation. We have to solve for this equation, okay? And now we're going to introduce this thing called the null factor rule, okay? So the null factor rule, all right? And it's very simple. Before we get going, I'll give you an example. If I have x times y is equal to 0, well, what are the values that could be x or y in for this equation to be solved? Well, there's only two possibilities. X would have to equal to 0, because 0 times y would be 0, or y is equal to 0. So whenever I have an idea where I have one block here and I multiply it about against a separate block, okay, so these are attached with multiplication, I can separate them and equate them both to 0. Okay, and if you're wondering, well, how is this going to help us? Let's give an example of this certain ax squared plus bx quadratic, and we'll see how it works. So imagine I start with something like this. X squared plus 4x is equal to 0. So if I solve for x, what we need to do in this format where I have the x squared and the 4x, so the ax squared plus the bx, is we need to do a table method. So if I look at this, you can see that I have something common on each table, like so. And now we're going to use this null factor rule. So here is x is one block multiplied by this other piece here, this, all right? So that's kind of like my x and my y. So if I do that, I can use this null factor rule that says take this x and equate it to 0, and take this x plus 4 and equate it to 0 as well. And now we can solve for this one. Now, of course, this is already done. We already know our solution. It's x is equal to 0. And now we have our other solution. If I put the x here, or the 4 on the other side, I have x is equal to negative 4. So my two solutions in this case are x is equal to negative 4 and x is equal to 0. So there's two solutions, just like I said previously, a quadratic creating two solutions. Okay, let's try one other one. So let's say example 2. If I have something like this, 3x squared is equal to 9x. Now you notice it's not exactly the same as this other one. On this other side, we had both terms on the same side equating to 0. So if you notice that you have the x squared term, which we do here, and the other term is on this side, so this is like my ax squared here. And actually, I've put my bx on the other side here. So when you have ax squared and bx, we want to put those on the same side. So if I put that over there, we will have 3x squared minus 9x is equal to 0. And then you will notice that we can actually do the table method here for this one here. So if we do the table method, you should realize what's common on each table. Well, if I go here, there's a 3 which is common on each table, and there is an x. And if we check to see what's left over on this table, there'll be an x left. And if you've taken the x off here and a 3, you subtract 3 and we have 0. And now we're ready to do the null factor rule. So we have this can either equal to 0 or this piece can equal to 0, just like we did above here, just like I showed you with the x and the y. So if that's the case, let's solve them separately. 3x is equal to 0. Well, if you divide by 3 on each side, you still get x is equal to 0. So here's a hint. In this format, when you have the ax squared plus the bx, one of your solutions will always be x is equal to 0. Always. So there's a big hint. So notice here I have x equal to 0. And in this example, I also had x equal to 0. So this will always occur. And then the other piece that we can set to 0 is this x minus 3 is equal to 0. You put the 3 on the other side and you have x is equal to 3. So here's your two solutions for this type of quadratic here. Okay, the third type that we want to look at to try and solve is this type where you have types C here. I call this C. So we have A, B, and C. I call this B here. All right. So in this case, we have all three terms in the quadratic. Ax squared plus bx plus c is equal to 0. So if we have something like this with all three terms, then it's quite easy. All we need to do is use the box method. So two numbers that multiply to get 3 but add up to get 4. So what are those two numbers that multiply to get 3 but add up to get 4? Well, you should get 3 and 1. All right. So now that we've factored these out, now this is exactly like what we did before. It's the null factor rule. Now, if you're good at the null factor rule and you understand it, it's quite easy. What you can do is you can ask yourself, what number goes into x so that I add that 3, so this whole thing becomes 0, and you can see it's minus 3. And then you can look at this side and say, okay, what number would I have to put into this x? So I add 1, so this side is 0, because that is essentially what the null factor rule is doing. So in this case, you would put -1 in that side. Now, if you don't really understand that, what you can do is just come along here and use the null factor rule separately. So you equate this piece to 0. You equate this piece to 0. Throw the 3 over there. Throw the 1 over there. And you get the same answers as if you were able to just look at this and guess, okay? So that's if you have this type here, which is unfactored. Now, there are some questions in the book that start you off and they're already factored. So let's just take a look at these ones using the null factor rule. If I do that, for example, 2x plus 1 times, let's imagine, x minus 2. And that's all equal to 0. So in this example, you can see it's already been factored. You don't want to distribute. The whole point of solving a quadratic equation is if you have this format here, you have to factor first, and then you can equate these separate pieces here and here to 0. So now that we have these pieces and they're already factored, it's easy. You just set each piece of them equal to 0. So that's piece number 1 and piece number 2. Piece number 2 is a little bit easier. You could probably do it in your head. You could just realize, okay, 2 goes over there and you have x is equal to 2. Okay. On this other one, it's not as easy. You can put the 1 over there, so you have negative 1. And you divide by 2, and I have x is equal to negative 1/2. Okay, so if we've already have the factor version of this, we don't have to factor, of course, okay? And once again, this is when we have 3 terms. There's only one other example I want to give you, and I will give it to you in a moment here. So the last type that we expect to see in the book is something like this one here. So I will write it a little bit bigger. If we look at this type here from question A, we have x minus 2 all squared is equal to 9. All right. So we explored one that looked like this, say 4x squared is equal to 16. What we did is we divided by 4 on each side, and we had x squared is equal to 4. And then we square rooted both sides, and we had x is equal to, don't forget, positive and negative, right? So positive and negative 2. So if we go and do that here, now notice that we have an x minus 2 and it's all squared. So we can use the same idea. Whenever you have a block which is squared is equal to a number, so imagine I have 100 here. To get rid of the square, we can square root both sides. So we have that is equal to, once again, plus minus. So it's going to be plus minus, and the square root of 100 is 10. So what we're going to do here is I'm going to square root this whole side, and add my plus minus here. And what that does is it frees up my x minus 2, and there's no longer this squared here. We've gotten rid of the squared. And on this side, of course, if I square root 9, I get plus or minus 3. Okay? And our final step, if this is a linear equation, would be to put this 2 on this side. So we'd have x is equal to positive 2 plus or minus 3. And in this case, we have to evaluate both answers. So what you should do is rewrite that as 2 plus 3, because that's one answer. And the answer is going to be 2 minus 3. And if we do that, we get 5 for one answer, and we get negative 1 for the other answer. So our two answers in this case is x is equal to 5 and x is equal to negative 1. So these are our two final answers. So if in this format, we have to square root both these sides. So if we now can go back to the book and look at all the different possibilities we have. So I found the page here. So let's just go over some of them here so that we can see how similar they are to some of the questions. Well, in the first ones here, you can see that they're factored, so you can use the null factor rule. So x is equal to 0, or x has to equal to negative 3 to make this piece 0. And you can look and you can try every bracket and solve them using the null factor rule. okay? So these ones have already been factored. So you just have to look and ask yourself, well, how do I get 0 in this bracket? Well, x has to be equal to 1. 1 minus 1 is 0. How do I get x, or this bracket, to be 0? That's the null factor rule. X has to be 3. So some of these you can visually just look at. Other ones you might have to write out and equate them to 0. All right. If we scroll further in the book, here are some table method guys. Notice we have an x squared piece, which is our first x squared term, and then we have our 12x term. So we have to do table method for all these. And in some of them, the second term is on the other side, so we have to bring it over here. All right. So it depends on what you have to do. But with these types, you have to bring both of them over to the same side. Now we're getting into other ones where we have 3 terms, and the 3 terms is when we need to use the box method. Now notice in this example we have 3 terms, but the 48 is on the other side of the equal sign. If you have 3 terms, you must bring all 3 terms to the same side and equate it to 0, just like A, B, and C. So if you look at E, F, G, H, I, J, K, and L, you should take all these 3 terms and make sure you put them on the same side. Don't forget to switch the signs when you move them over, okay? Question 3 is getting a little bit more difficult. So you have to factor out some numbers. So there's a common factor of 2 in 2x squared, 16x, and 24. So you can divide out the 2 and then use the table method in here, okay? Or pardon me, not the table method, the box method, because there's 3 terms, okay? And once again, we have even more difficult ones, but try the easier ones first. And in questions 5 and 6, you have to expand first, and then you have to solve the quadratic equation. And these are getting into now looking at 6 and 7 type questions. So there's your tutorial now for solving quadratic equations.